Assalamualaikum.
Good afternoon, Professor Toshinori.
Hello, good afternoon.
Good afternoon, Tsuru Sensei.
Yeah, hello, how are you?
How are you? I'm fine, thank you.
It's a long time you left for Indonesia.
Professor,
Yeah. But mostly
Hello, good afternoon.
every year I visit Mother Sensei.
Yeah, hello, how are you?
How
Hello, how are you?
Thank you.
Thank you all for inviting me. Long time you left for Indonesia. Pardon me?
But
Hello,
mostly every year I visit Mother Sensei.
Yeah, hello, how are you? Hello, how are you? Thank you all for inviting me. Long time you left for Indonesia. Pardon me?
But mostly every year I visit Mother Sensei. Ini mungkin yang Zoom itu double, jadi Guru Siti Nur.
Something wrong.
Iya, siapa yang double? Ada Zoom yang double.
Yang live streaming dimatikan aja mungkin, Bu.
Oke, sudah ya?
Sudah, Bu.
Okay, maybe we can start, Professor Toshinori.
Yeah. Hi, yes.
Okay, Anissa, you can start.
Okay, good afternoon, ladies and gentlemen. Welcome to our guest lecture of membrane technology. Today, I am Anissa from ITS Chemical Engineering Department, will be your master of ceremony. First of all, I would like to thank all of you for joining our guest lecture today. And before we start the agenda, let me inform you some of the rules. During the lecture, please turn off your microphone and only turn on your microphone when the moderator gives you a change. And for the participants, you could ask questions during the question and answer session by using raise hand feature or dropping your question in the chat room. Okay, today's guest lecture will present a topic entitled Silicon-Based Membranes with Molecular-Net-Sieving Properties, that is, application to gas and liquid phase separation, that will be delivered by Professor Toshinori Tsuru from Chemical Engineering Program at Graduate School of Advanced Science and Engineering of Hiroshima University, Japan. And also, the guest lecture today will be moderated by our moderator, by Mrs. Siti Nurhamida, PhD from ITS. Okay, for the next agenda, there will be an opening speech by Chemical Engineering Department, ITS, that will be delivered by Mr. Dr. Ang Kusdianto. For Mr. Dr. Kusdianto, the time is yours.
Okay, thank you very much, MC. Good afternoon. And honorable Professor Tsuru as the speaker, and honorable to Dr. Susianto, Dr. Siti Nurhamida, and our student. It is our great pleasure to be here as a representative of Chemical Engineering Department, ITS. Our chairman, Dr. Widya Stuti, sent the best regard to Tsuru Sensei because she is not able joining this event because she has another meeting, Sensei. So Dr. Widi is also gained the PhD from Hiroshima University from Okuyama Laboratory. Today it is a great day because we have the special guest lecture here delivered by Professor Tsuru from Hiroshima University. And also we really appreciate for your willingness to participate for the guest lecture in our department. So we believe that your participation in this event will strengthen the collaboration between our institution and allow our students to gain the additional insight and knowledge. Additionally, we have the 36 lecture in Chemical Engineering Department ITS Tsuru Sensei, and 33% are Japan alumni, and 25% is gain the PhD or master is from Hiroshima University. So mostly is Hirodai no alumni des. Okay, thank you very much for the Tsuru Sensei for time to share the knowledge about the membrane technology to our student. Mostly the participant is undergraduate, Yonense and Sanense, and but we invite some the graduate student to joining also this event. So this is all for me, and I will give time to MC.
Okay, thank you very much for Mr. Kusdianto for the opening speech. Okay, before we jump to the next agenda, let me introduce you our moderator today. Good afternoon, Mrs. Siti Nurhamidah.
Good afternoon, Anissa.
Okay, without any further ado, let's start it to our main agenda that will be guided by Mrs. Siti Nurhamidah. To Mrs. Siti Nurhamidah, the time is yours.
Okay, thank you. Good afternoon, Professor Tsuru. Before we start our seminar, I would like to get permission for you. Is that okay if we have live streaming on YouTube?
Yeah.
For the documentation.
Okay.
Is that okay?
Yeah. Yes.
Okay, thank you. Okay, before we start the meeting, I would like to introduce our speaker today, Professor Toshinori Tsuru. He came from Department of Chemical Engineering, Hiroshima University, graduate from University of Tokyo for bachelor, master, and also doctor of engineering from University of Tokyo. And her research and professional experience. Oh no. Okay, he was a board member of Society of Chemical Engineers in Japan and also a member of Science Council of Japan. And his research interests, the first is preparation of inorganic and organic hybrid membranes via sol gel processing and atmospheric pressure plasma enhanced chemical vapor deposition, and also nano or sub-nano porous membranes for gas, PV, and reverse osmosis or nanofiltration, and also transport mechanism through nano or sub-nano porous membranes, and also membrane reactor for hydrogen production. And he got award from the SCEG award from the Society of Chemical Engineers Japan, and also SCEG award for outstanding research achievement, and also from the Society of Chemical Engineers Japan. Okay, I think that was the main point for his curriculum vitae. Okay, Professor Tsuru, maybe you can start your meeting.
Okay. Thank you very much for your kind introduction. Good afternoon, ladies and gentlemen. First of all, I would like to thank the committee member to give me the chance of talk for the student of Department of Chemical Engineer of ITS Surabaya. Especially, I would like to thank Dr. Susianto for inviting me. Thank you very much. Today, I'll start to share my slide. Just a second. Okay, can you see my slide? Okay.
I'm sorry, Professor Tsuru. Looks like the Zoom meeting, we only have 7 minutes left. So maybe if we stop, we can join again with the same Zoom meeting link.
What do you mean? Is something wrong?
Yeah, I don't know, because Pak Susianto, who make the Zoom, Zoom meeting, who created this Zoom meeting. Looks like we only have 7 minutes left.
Mhm.
I'd like to upgrade, but I cannot. So maybe if the Zoom meeting stop, maybe you can sign in again, join again.
Okay, join again. Okay, okay. So now rejoin again. Okay, okay, just quit at this moment.
Yes.
Okay. Oh, okay. I see.
Thank you.
Yeah. Hello, can I start my talk?
Okay, you can start, Professor Tsuru.
Okay, okay, okay. Share slide again. Can you see my slide?
Yes, we can see.
Okay, okay, good. So I will start my talk. But anyway, thank you again for inviting me for giving this talk. Okay, my today's talk is now silicon-based membrane with molecular-net-sieving properties, application to gas and liquid phase separations. I will start my talk by giving the short general introduction, including membrane technology, as well as porous inorganic membranes and permeation mechanisms, which will be beneficial to understand my talk of today. Second part of my talk with mostly the membrane fabrication, such as silica and organosilica membranes, and then move to the application of various fields. And then I would like to say something about the concluding remark. Now, before starting my talk, I'd like to share with you my research groups. My research group is now named as Separation Technology Laboratories, consisting of 3 faculty members, including myself, Associate Professor Dr. Kanezashi, Assistant Professor Dr. Nagasawa. We fabricate mostly inorganic membranes, such as metal oxide, such as silica, titanium, silica zirconia, hybrid or silica titanium. Also, we have working on inorganic hybrid materials, such as organosilica, via soldier processing or low temperature plasma. These membranes have been used for mostly hydrogen separation and production, and also CO2 or hydrogen over organic gas is also our interest. These membranes are very much good for applying PV, power evaporation, and vapor permeation, such as dehydration of organic solvent, such as alcohols and other mixtures. And also, we have worked on nanofiltration and reverse osmosis. And then our interest is also extending to membrane reactors. I'd like to briefly introduce my research activity, membrane reactor, later on. Now I'd like to start my talk by giving this slide. Maybe some of you may know this slide. This slide, this paper, this article was published in Nature 2016 by Professor Shoro and the Ryval, as entitled as 7 chemical separations to change the world. These guys are from the Georgia Tech. I know them very well. And then they mention about the total US energy consumption. As you know, 1/3 is now transportation and 1/3 is for industry. The rest is now residential and commerce. When you look at the details of industries, around 50% is used for energy consumed by separation processes. And then 50% is now distillations, 20% is now drying, and 11% is evaporations. The thermal separation cost more than 80% energy is used for separations. And then they introduced the membrane-based separation would use 90% less energy than distillation. So this is very much good figures for people who are working on membrane technologies. They mention about several separation systems such as alkene from alkane, hydrocarbon from crude oil, uranium from seawater, greenhouse gas from dilute emission, rare earth metal from ores, benzene derivative from each other, and trace contaminant from water. So anyway, what I want to say is that membrane-based separation will be able to replace thermal separation such as distillations. So we need to develop good membranes for separations. Okay, as you know, the membrane separation technology is now, simply the feed is separated into the permeate retented streams. Membrane can be categorized in the several viewpoints. From the viewpoint of the materials, polymeric membranes, inorganic membranes, and hybrid membranes. Our research groups focus on inorganic, ceramic, and also hybrid membranes. From the viewpoint of the mechanism, membrane permeation mechanism can be categorized into the molecular sieving or diffusion, affinity diffusivity-based separation. It is called as a solution diffusion model. For the case of the non-porous membranes, for the case of the solution diffusion model, and the porous membrane case, the mechanism is based on molecular sievings. These membranes can be applied for many applications, including the energy issue, like a hydrogen